Today you will learn about solubility of gases in a solution. So there's some different things that affect how well a gas can stay dissolved within a solution. The first one is temperature. So you guys probably have experienced this with a can of soda. So if you open a can of soda and you put it in the fridge versus leaving it outside on a hot day, the can of soda in the fridge is going to stay more carbonated than the can of soda that's left outside. The reason is because in soda, carbon dioxide is a gas that's dissolved in it, and that's what carbonates your soda that you drink. And so by placing it outside in a hot day, that actually causes the molecules to move around more quickly, and as a result, that carbon dioxide can escape from the solution and enter into the atmosphere. Whereas in the fridge, where it's cooler, the molecules are moving more slowly and it's going to take longer for them to escape out of the solution. Now this is also happening like in our lakes in the summertime. So when lakes get really warm, it becomes more difficult for oxygen gas to stay dissolved in the lakes. And we experienced this at Renwick a few years back when we had that really hot summer. There were a lot of dead fish that were showing up, and they think that it was caused by the low oxygen levels because it was so hot that oxygen was escaping and there wasn't enough oxygen to provide for the fish to be able to live. Another thing that affects the solubility of gases is the pressure. So the more pressure you put on that liquid or that solution that has gas dissolved in it, the more likely that gas is to stay dissolved in there. However, if the pressure is released, then that gas is able to escape. So the example would be if you have a bottle of pop with a lid on it versus having no lid on it, the pressure actually helps to keep your pop carbonated and force the carbon dioxide to stay dissolved in the solution. But once you open it up, that carbon dioxide is able to escape due to the lack of pressure. The law that relates to the solubility of gas in a solution is called Henry's law, and it simply states that the solubility of a gas increases as pressure increases. So here's our basic formula. Make sure you write it down on your formula chart. The beginning solubility divided by the beginning pressure equals your ending solubility divided by your ending pressure. And in this situation, solubility is the mass in grams of a substance divided by the liters of solution. So make sure you get both of these formulas on your formula chart. We're going to work through some problems using Henry's law. The first problem is if you have 0.55 grams of a gas dissolved in 1.0 liters of water at 2 atmospheres of pressure, how much will dissolve at 4.5 atmospheres of pressure? So in this situation, we have our grams of gas in the liters, and we know the pressure is in 2 atmospheres. So we need to actually figure out the solubility, and you would just do that by using this first formula, our second formula, solubility equals mass divided by volume. And by doing that, you would take 0.55 grams divided by 1.0 liters. And so anything divided by 1 is that number. So the solubility is 0.55 grams per liter. Now that we know that, we can use this first formula, S1 over P1 equals S2 over P2. And in this situation, we have our 0.55 grams per liter. That's our S1 value. We know it's at 2 atmospheres, and it equals the S2 solubility when the pressure is changed to 4.5 atmospheres of pressure. Now, when looking at this, you're increasing the pressure. So based on that, your solubility should increase if the pressure is getting higher. And as always, when you have something set up as in fractions like this, you're always going to cross multiply your two numbers and then divide by the other number, by the one in the denominator. And so the answer ends up being 1.2 grams per liter, which is larger than your beginning solubility, and it should be. Now with sig figs, because we only have 2 atmospheres of pressure up here, we're going to have just 1 sig fig, so our answer is 1 gram per liter. The next problem states that a gas has a solubility of 0.66 grams per liter at 10 atmospheres of pressure. What is the pressure on a 1.0 liter sample that contains 1.5 grams of gas? So this is our ending pressure and solubility, but we're solving for the ending pressure. But to do that, we first need to figure out what the solubility is. And so then we would take our 1.5 grams of gas divided by 1.0 liters as our volume, and you get 1.5 grams per liter. Now, this might be obvious that it would have been 1.5 grams per liter, but in some of the problems you work, you may not always have a volume of 1.0 liters. It just happens to be in these first two problems that that's what the volume is. Now we need to set up our next formula. So we have our starting solubility, 0.66 grams per liter, divided by our starting pressure, which is 10 atmospheres. That equals our ending solubility, which we calculated right here, 1.5 grams per liter, divided by the ending pressure. Now again, we're going to cross multiply these two numbers and then divide by our 0.66. And when you do that, you get 23 atmospheres. Now because we have 1 sig fig here, we would want 1 sig fig in our answer, so it should be, the final answer should be 20 atmospheres of pressure. Here we have our last problem. It says if 0.68 grams of gas at 5 atmospheres of pressure dissolves in 1 liter, 1.0 liters of water at 25 degrees Celsius, how much will dissolve in 1.0 liters of water at 8 atmospheres of pressure at the same temperature? All right, so first we need to figure out what our solubility of this gas is. So we have 0.68 grams per 1 liter. So again, it's going to be 0.68 grams per liter. So that is our S1 value. And then we need to plug that into our change in solubility and pressure. So here's our starting solubility. It's at 5 atmospheres of pressure, equals our ending solubility that is at 8 atmospheres of pressure. Once again, you're going to cross multiply and divide. So you're going to cross multiply 0.68 times 8 atmospheres of pressure and divide by 5 atmospheres of pressure. And that gives S2 a value of 1 gram per liter. And again, we're going to use 1 because we had 1 sig fig in this problem. But the question is asking how much will dissolve. So we know what the solubility is, but we need to figure out how much is going to dissolve in 1.0 liters of water. So now you need to go back to your solubility formula equals mass divided by volume. We know our solubility is 1 gram per liter. We know our volume is 1 liter, and we need to solve for our mass. So you would end up multiplying these two numbers because this one technically is in the numerator. This one's in the denominator. This would be over 1. And when you do that, obviously 1 times 1 is 1. So our mass is 1 gram. We have 1 sig fig here, which is what we should have when we look at our atmospheres of pressure.